Hi, my name is Kevin Chen. I'm a product manager at Keysight Technologies. In this video, I will introduce HRP UWB technology defined in IEEE 802.15.4 or 4Z. Then I will talk about Keysight HRP UWB testing solution. Now, there are some different wireless technologies for indoor positioning like Wi-Fi, Bluetooth, RFID, and UWB. They are using different positioning methods, such as received signal power used by Wi-Fi, angle of arrival or angle of departure used by Bluetooth, time of flight used by UWB, or just a remote coupling used by RFID. HRP UWB is operating in sub-GHz, low band below 6 GHz, or high band above 6 GHz, and it uses impulse modulation. It has some advantages as long ranging and provide more accuracy compared with other wireless technology positioning. Beyond indoor positioning, UWB can also be used as seamless access control and device-to-device or peer-to-peer services. UWB means ultra-wideband, which should be either over 500 MHz or the bandwidth is relatively wide enough, more than 0.2 compared with the center frequency. But there's a strict power spectrum density definition for UWB signals. As FCC definition, it should be lower than -41.3 dBm per MHz. Impulse radio-based UWB is firstly introduced in IEEE 802.15.4a standard in 2007 for indoor positioning purpose. Later, it evolves to the 802.15.4 standard in 2011. Then it is modified in 2015, including two different physical layers. One as HRP, high rate pulse repetition frequency, also called HRP UWB, and another is low rate pulse, coming from 802.15.4f, and also known as RFID. In 2019, there's an amendment as 802.15.4z, which modified the UWB physical layer and mic layer contents. Now, the HRP UWB technology has raised more marketing attention, and there's good ecosystem based on it. There's chipset modules based on HRP UWB, and devices and applications developed based on HRP UWB. There are also several consortiums for UWB. One is UWB Alliance and another is FIRA. Many chipsets, modules, and devices makers have joined those consortiums to contribute and work together for conformance testing and interoperability. 802.15.4z introduces a new mode known as HRP ERDV, meaning Enhanced Ranging Device, which includes two modes as BPRF, Basic Pulse Repetition Frequency, as 16.4 MHz, or HPRF, High Pulse Repetition Frequency, as 128 or 256 MHz. 802.15.4z has the advantages to reduce airtime for higher density and lower power consumption, and also increase the integrity and accuracy for ranging measurement time steps. The typical ranging can be up to 100 meters. What are the HRP UWB test challenges? First, as a standard definition, it can reach high band at 6 GHz to 10 GHz frequency, and this is the mainstream of the chipset on market. It also requires the wide bandwidth, as the minimum bandwidth requirement is around 500 MHz. HRP UWB transmitters or receivers must conform to the RF requirements defined in 802.15.4 standard, in which their operating band, channel assignment, baseband impulse response, transmit mask, receiver maximum input power, LQI, CCA, etc. measurement definitions. What can Keysight provide you for HRP UWB measurements? First, we have the HRP UWB signal generation solution based on N7610C IoT Signal Studio. It can support all of the HRP UWB modes as non-HRP ERDV mode or HRP ERDV, BPRF, or HPRF modes. You can also configure all of the channels and bandwidths as defined in the standard. Header or PSDU physical layer or up layer parameters can also be customized. Beyond the signal itself, you can also add some impairments like symbol timing error or function offside, and also add multipass at channel settings. Keysight has different hardware platforms which can meet the high band above 6 GHz frequency and 500 MHz above bandwidth. E7760A is a wideband transceiver which can both generate and analyze signals with a single instrument, so it is mostly recommended for wideband wireless technology, design verification tests, or manufacturing customers. Furthermore, Keysight also have benchtop signal generators like M9384B or M9384B VXG or M9190A plus E8267D PSG. They can also generate HRP UWB signals and are recommended for R&D customers. For HRP UWB signal analysis, Keysight has the flexible 89600 VXA software, which can also support all modes and bandwidths defined in standards. There are some RF requirements defined for HRP UWB transmitter testing, like baseband impulse response, transmit mask, function error, and chip clock error, and all of those are also supported and has an easy pass-fail indication shown in the 89600 VXA software. For HRP UWB signal analysis, you can also leverage the E7760A wideband transceiver. Keysight also has some benchtop signal analyzers for 6 GHz above frequency and 500 MHz above bandwidth HRP UWB measurements, like X-series signal analyzers, MXA N9021B, PXA 9030B, or UXA 9040 or 9041B UXA, and also UXR series Infinium oscilloscopes. All of them can work with the 89600 VXA software for HRP UWB transmitter measurements. Now let's take a quick look how Keysight can use software together with instruments to generate and analyze the HRP UWB signals. N7610C Signal Studio plus M9384B VXG are used for HRP UWB signal generation, and then we use the 89600 VXA software plus the N9040B UXA for HRP UWB signal analysis. Now, let's see how we can generate HRP UWB signal with VXG instrument. Firstly, click System menu and then choose Run System Configuration Wizard. It will pop up a window, and we choose the M9383B and M9384B VXG and then click Next. Here we configure the VXG instrument with IP address. Choose the previously configured VXG and press the View button. Then you can see it has connected well to the VXG instrument. Now click the hardware instrument on node tray. Then you can configure some parameters for the VXG instrument. You can specify the channel number, center frequency, RF amplitude, and other parameters. Then let's move to the waveform setup node. Here you can see that N7610C IoT software support many standards. And here we choose the 802.15.4 HRP UWB standard. You can also configure the waveform name, number of frames, and oversampling ratio, other parameters. Next, let's move to the HRP UWB node. First, we need to choose the HRP UWB mode, which can support non-HRP ERDV, HRP ERDV, BPRF, and HPRF stream modes. Here we choose the ERDV HPRF mode. Then you can continue to configure the STS configuration, channel number, header settings, PSDU settings, physical payload STS settings. Last but not least, you can also configure some impairments such as symbol timing error, function offside, customized shipping filter, and multi-pass settings for HRP UWB signals. Once you complete all of the settings, please press the download icon on the top left of the window. Then wait a while. It will first calculate the waveform and then download it into the M9384B VXG. Now let's connect to the M9384B VXG to see what's happened on the instrument GUI. You can see that we have downloaded the HRP UWB demo waveform into VXG channel 2 and loaded it into the memory. Then you can see that for channel 2 output, the center function and power are also set up. Modulation and RF output are also turning on with the HRP UWB signal generation for testing now. Now, let's move on to see how we can analyze the HRP UWB signal with 89600 VSA software and UXA instrument. Firstly, click the Utility menu to set up the hardware. Here you can see that we connect the 89600 VSA software to a N9040B UXA for measurement. Then select the Measure Setup menu and then select the measurement type as well as connectivity, and then choose the IEEE 802.15.4 HRP UWB. Once complete, click the HRP UWB Demote Properties, where you can configure parameters for HRP UWB signal analysis. You can firstly configure channel number. In this demo, we use channel number 9, and then choose the physical mode. Here we should choose the ERDV HPRF mode. Then you can follow on to configure the SHR parameters, PHR PSDU parameters, and then STS parameters. After all parameters are set in correctly, you can see the HRP UWB signal analysis results on the window. On the left, you can see a numeric result window in which it has the function error, channel power, chip clock error, main lobe and side lobe results. You can also see the limit test for mean main lobe wise and maxi side lobe results with pass-fail indication, and also the power measurement result for HHR data and STS each section. On the right side, there are some other trace measurement results for HRP UWB. On top left, you can see the spectrum trace of HRP UWB, where I add a band power measurement. You can see the result at the bottom window around minus 11 dBm. On top right, it is time domain trace result for HRP UWB. You can see there are 3 pulse frames shown here in the time domain. On the bottom left, it is HRP UWB transmit mask trace result with pass-fail indication at the bottom window. On the bottom right, it is HRP UWB RC correlated results as IEEE 802.15.4 standard definition. Ideal pulse will correlate with the received pulse to get this result. Thanks for watching this HRP UWB introduction and demo video. For more information, please visit www.keysight.com website.